let me tell you a little bit more about big data and what we're dealing with, what the problems look like with data in the real world, so you can understand why I'm so excited about these graphs. So let me show you what most of the information, when you think about big data, right, you hear terabytes and you hear all these pieces of like crazy technology with AI and stuff like that. What it really looks like on the ground is this, right? Documents, papers. There are so many pieces of paper with ideas and information that have been published for, hundreds of years, not just like this in actual paper form, but on the internet and on database servers. So, I'm talking about PDFs from businesses or books from authors or, you know, just the materials that you made for notes in your college classes or your high school classes. All of that stuff is useful, and if we could see it all together, that would be very interesting. But unfortunately, it's locked up in these pieces of paper that no one really knows what are about. And there's a way to get that out, right? So we can use natural language processing, which is a kind of AI, to read all of these things and take out the concepts and kind of help us structure what is inside the document so we can access it both for ourselves as people, but also for machines who help, do things through AI. So that's kind of the first step, is taking unstructured data, like what's in papers, and putting it into structured data. And that looks something like this, right? So there's a couple different ways to get structured data. You can pull it out of documents like I was just describing, or you could actually capture it that way. So, there's some things that make sense to kind of put into an Excel spreadsheet, like what we're looking at. Information about costs or numbers in general, times, things like that. There's a lot of Excel spreadsheets in business, and they get to be really big because as you're dealing with more and more complex issues, you find that you need to add more data and more rows and more columns. So in this example, we can see that there's 24 rows and probably about 18 columns or so. We're all the way into like O, right? From A through O. And you can imagine that it would probably take you a long time if you were trying to look through this and like think about whatever this is about and analyze it and say, what is happening that this data spreadsheet is showing me? It would probably take you a while just to move your eyes over all the columns and get that data out of it. But imagine that you have a business size spreadsheet, right? So some of those, and I kid you not, are 20,000 rows long and 2,000 columns, or I've even heard of 1,000,000 rows. So that's obviously not even possible to look at, right? And like, think about how many times you have to look at this. It's every time you have a question that you need data for, which you can imagine in business is like very frequent. You have to find it by hand. And of course, we've automated this a little bit, right? So we have something called SQL. It's a computer language, just like Java or R, but it's meant for querying databases, asking questions out of databases. And so if you wanted to get some information, you kind of have to know what's already in that spreadsheet and make a SQL query that says, hey, go fetch this from there. And as you can imagine, when you hear about big data, when you think about how many businesses there are and how many spreadsheets there are and how many rows and columns there are in the world, we're looking at like 100 trillion billion research papers, right? That first activity that we just went over, that you kind of have to search and find and hunt and put everything together, that is happening all around the world all the time, every time you have a question. And there's something about the way we have our databases. It's called relational databases with the Excel sheets and the SQL that I was just talking about. There's something even worse than what I just explained. That's called join, right? So imagine that you have a question that actually needs you to look at more than one spreadsheet, right? Now, if you're a human being, you can open that up and you can just check it. But when you have these giant scale documents like we were just describing, you really can't rely on that anymore. So we have to use SQL. And the way to do that in SQL is called the join function. You actually literally have to tell the machine to connect one spreadsheet with another spreadsheet with another spreadsheet to get your answer. So that's what this picture is showing us, right? We have spreadsheet 1. spreadsheets 2 and 3, and spreadsheet 4. And we're using all of these to actually just answer like a fairly simple question. What department does Alice, my employee, work in? So you're going to find the spreadsheet that has Alice and her code, right? So you can search for Alice in other spreadsheets. And then you're going to go to the spreadsheets that have that code plus all the department's codes. And then you're going to search like wherever Alice's number appears, you're going to look for those codes. And then you're going to translate those in the last spreadsheet from department codes into like actual descriptions. And then you can answer the question. And each time you do this join function, it's actually really expensive. It takes a lot of compute power, and it's costly, right? It's time consuming and it costs money, and it requires data analysts who know how to use SQL to be available, have time to say, yes, let me drop everything else on my plate and like find this out for you. So there's a lot of bottlenecks with actually accessing all the data that we have. And I saw a statistic that there's only like 0.5% of all the big data that exists is actually being used. So you can imagine the scale of this problem and what we could do if we had access to all of that kind of data. So the solution is, in my opinion, and many others, is graphs. With a graph, instead of doing that costly join function because you have all of your data in different places, you just combine everything that you know on one topic into a different database structure, a graph structure, right? So looking at the previous picture that we just saw, we have 4 spreadsheets here, which I just went over. Instead of that, we can have one graph that shows Alice as a node or like a circle on that graph, and then all of the things that she connects to. So she has relationships to the department that she's in, the 3 different departments that she's in. And we can build that at the beginning. We can combine all that information when we have it, like we can sort it and we can put it up there together so that anytime I have a question about Alice or about the department she's related to, it's already in there. I don't have to go and say, hey, computer, build this custom report for me. I can just go ask it. It already exists, right? And so that has a lot of value. Not only is it great to have all the relevant information clustered in one spot, which allows us to like access it a lot more easily and see all the things that we don't know about that we would probably benefit from knowing, but we can also see all the connections, right? So Alice is connected to the department, but she may be connected to a million other things, and it might be useful to know that. So we can also show all of those things, which is really hard to show in any other way, right? If you can't just like add a new line on the graph. And then if we imagine this as more than just Alice, but there's lots of people in this business and there's lots of different things that they can be connected to, or maybe beyond business in the education space or in some other space, we could see the whole system. We could see who's there and what they're like and who they're connected to, and we can make decisions based on that as well. So it's very powerful. So here's an example with an education knowledge graph. This would be called like a schema or an ontology, right? Which, don't get scared of words. It's just like boxes and lines. So you can see at the top, there's these 3 white boxes, and these describe a type of person, an academic or just a regular person and a teenager. And then we see types below here. So the way to read this is a high school student is a type of student, an elementary school student is a type of student, a full-time student is a type of student, and also a high school student is a teenager, right? And there should really be a line here between person and teenager that would show us that teenagers are people. And we could also see that there could be a line between full-time student and elementary school student, or full-time student and high school student. So we can see that there's multiple ways of like thinking about each thing. Not only am I a teenager, which means that I'm a person, which means that maybe, you know, I have a lot of other things like friends and like certain interests, but I'm also a full-time student, and I'm also in high school, and I'm also all these other things. So you would start with something like this if you were thinking about like a person in education, and you might do something like add your name into a schema, right? So now all of a sudden we have an instance of this high school student persona, and it's your name, right? And then we might want to know what classes you're in. So we could have a new subject called courses. And then we could break that down into the different kinds of courses that are available, like arts and algebra and English. And then we can show which courses you're in. So you are in English, let's say. Why is this important? Well, it's interesting to be able to just look at this kind of structure, but it allows you to ask queries that are more sophisticated than what we can do right now. So for instance, you could actually ask this knowledge graph, who is in my class, right? It would go through and look at all the relationships that you have to classes like English or algebra or art or whatever you're in. And then it would also look and see who else is in those things. And it could give you a list easily. You could also ask it, who can I get notes from if I miss last Tuesday's class? And that would just be adding an additional piece of data that talks about attendance, right? And so it would look at everyone who attended that class, who's also in it, and it would pop that out for you. And you could also ask something much more advanced, like, how do I build a startup if you had pieces of information that were attached to a structure like this, all laid out so that the computer could kind of say, well, you know these things, and these are the things you also need to know, so these are the things that you should study, right? Which we can see how that would be useful for an educational product. So these are the kinds of things that you can do with knowledge graphs, and there's a lot of other things you can do as well. You can look at complexity, which is kind of what I was talking about. You can see so many different relationships, pieces of information about topics that you can really formulate the gaze of everything that's important in a particular space. You can also use this for discovery, which is finding information you don't know about that's actually really useful. You can do this just by looking at the graph. Oh, I never knew John was in my algebra class, right? Like, hopefully you would know that just from being there, but there might be other kinds of situations where you don't have access to that information, but you can see it from the graph. It's also helpful for recommendation. So this is what Amazon uses to tell you what you might be interested in based on your purchases. And this can also be used for a lot of different kinds of recommendations. For instance, I know of a company that built a recommender system for oil and gas problems in the field. So when something broke, they could look back at all the things that they had like knowledge about, problems that had happened in the field, and recommend what was the likeliest path of solution. You could also recommend training, right, for education. You can see networks. Again, that's kind of all of the information and how it relates, which is really helpful for things like global supply chains, anything that's complex and has a lot of people and moving parts. And it's also really helpful for machine learning, right? So we're all excited about AI and algorithms and machine learning, but a lot of times what gets popped out isn't really explainable. We don't know what happened, and so it's hard to use. So knowledge graphs provide all of that information at the beginning, so the results you get from machine learning algorithms are a lot stronger. So that's basically what knowledge graphs are in a very small nutshell. Like I said, here's my email. You can ask me any questions that you like, or let me know that you're interested to learn more. And I really appreciate that you've been here to find out more about this.